and welcome to Eganeet. In today's video, we are going to study the ratios of areas of two triangles. Since we are going to deal with the ratios of areas of two triangles, let us first consider two triangles, triangle ABC and triangle PQR. Now, we are going to find the areas for both the triangles. And what do we need to find the area of triangle? Yes, the base and the height. If the base and the height of a triangle is known, we can find the area of triangle. Now, if I tell you that I draw a perpendicular from the point A to the side BC of triangle ABC, then what will be the height and the base of the triangle ABC? Correct. AD will be the height of the triangle and BC will be the base of the triangle. We denote it by H1 and B1. Similarly, in triangle PQR, if I draw perpendicular from the point P to the side QR, then what will be the base and the height of the triangle? Absolutely correct. This distance will be H2, the height, and this will be the base B2 of triangle PQR. Now, since we have the base and the heights of the triangles, we can find the area of triangle. And we also know the formula to find the area of triangle, which is half of base into height. Very simple. Now, what will be the area of triangle ABC then? Yes, it is half of B1 into H1, and similarly area of triangle PQR will be half of B2 into H2. Now, what is our concept? It is the ratio of areas of two triangles. We have the areas of two triangles. Now, we just have to take the ratio of them. So, let us take the ratio and we get this term. Clearly, half will get cancelled and we are left with the ratio of areas of two triangles, triangle ABC and triangle PQR on the left hand side, and what is there on the right hand side? It is again the ratio of the product of corresponding bases and heights of the triangles. B1 into H1 is the base into height of the first triangle, and B2 into H2 in the denominator is the base and height of the second triangle PQR. So, we can say that the ratio of areas of two triangles is equals to the ratio of product of corresponding bases and heights of the triangles. Here, in these two triangles, the base and the heights of the triangles are different. What if the bases and the heights of the triangles are equal? Let us consider it as condition 1, where we take the heights of the triangles as equal. So, condition 1, if the heights of both the triangles are equal, you can see in these two figures, how are the heights? They are equal and the bases are different. So, we take the base as B1 and B2 and height as simply H. Now, what will be the ratio of areas of the two triangles? Yes, it is very simple. It will be equals to B1 into H upon B2 into H, where we can cancel out H and H and we are left with the ratio of corresponding bases on the RHS. So, what we can say from here? That the ratio of areas of two triangles is equals to the ratio of corresponding bases when the heights of the two triangles are equal. You might have guessed the other condition. What can be the other condition now? Yes, the bases will be equal in the other condition. We take condition 2 if the bases of both the triangles are equal. We take BC as the common base for the two triangles, that triangle ABC and triangle PBC. We represent it by simply B, and since heights are different, so H1 and H2. You might have guessed the ratio of areas of the two triangles here. What it will be? Yes, it will be equals to simply the ratio of corresponding heights, that is H1 upon H2. So, whenever the bases are common for the two triangles, then the ratio of areas of two triangles is equals to the ratio of corresponding heights of the triangles. Now, let me summarize what we have done till now. If there was nothing in common between the two triangles, then the ratio of areas of two triangles is equals to the product of corresponding bases and heights of the triangle. If the heights are equal in the two triangles, then the ratio of areas of two triangles is equals to the ratio of corresponding bases. And when we took the bases as common, then the ratio of areas of two triangles is equals to the ratio of corresponding heights of the triangle. I hope the concept was very clear to you. It was very easy. Let us move to the practice problem. In the given figure, AP is perpendicular to BC and AD is parallel to BC. AD and BC are parallel lines. We have to find the ratio of triangle ABC and triangle DBC. We take the ratios on the left hand side, which will be equals to. Now, observe triangle ABC. What is the base here? Yes, BC is the base here. Now we observe the second triangle, that is DBC. What is the base here? Yes, again BC is the base here. So we can say that BC is the common base for both the triangles. Now let's observe the heights. AP is the height of triangle ABC. Now what will be the height of triangle DBC? Will it be same as the height of triangle ABC? Yes. Why? Yes, the distance between two parallel lines is always same, and here the distance between two parallel lines is nothing but the heights of the triangles. So the height AP will be equals to the height, say, DQ of triangle DBC. That means the heights are equal and the bases are common for both the triangles. So how will be the ratio? Everything will get cancelled out, the bases and the heights, and what we are left with is the ratio of areas of the two triangles here is equals to 1. And whenever the ratio of the areas of two triangles is equals to 1, that means that the areas of both the triangles are equal. I hope you have understood the concept. Now let us do a quick concept check. I have a quiz for you where we have two triangles, smaller triangle having the base as 9 and height as 5, the larger one having the base as 10 and height as 6. What we have to find? We have to find the ratio of areas of these triangles. Very easy, we have studied just now. My hint to you is this concept that we have just studied. What is it? The ratio of areas of two triangles is equals to the ratio of product of corresponding bases and heights of the triangles. Simply we have to substitute the values in this formula and we will get the answer. After substituting, the ratio will be equals to 9 into 5 upon 10 into 6, and after simplifying we will get the ratio of areas of two triangles, triangle 1 and triangle 2 is equals to 3 by 4. It was a very easy concept. Let's summarize this. The ratio of areas of two triangles is equals to the ratio of product of corresponding bases and heights of the triangles when the heights and bases are different in both the triangles. When the heights are equal, then the ratio of areas of two triangles is equals to the ratio of corresponding bases, and when the bases are common in both the triangles, then the ratio of areas of two triangles is equals to the ratio of corresponding heights of the triangles. And when the triangles lies between two parallel lines having a common base, then the heights become equal and the areas of the two triangles will also be equal. This is all for today. I hope the concept was clear to you. Keep studying and keep practicing.